Work equals force times the distance. That is a direct variation because on a graph, when you increase the force or increase the distance, the work also increases. Work is done on an object when an applied force moves it through a distance. For example, the man pushing the box. The examples of the simple machines are the lever, pulley, screw, inclined plane, wheel and axle, and wedge. Simple machines are tools that are designed to make work easier and have few or no moving parts. Simple machines reduce the amount of force needed to do work. They also never get tired and never ask for anything in return. That's a doorknob. Inclined plane. An inclined plane is a flat supporting surface tilted at an angle. Inclined planes reduce the amount of force needed to move objects vertically, making hauling, loading, and moving objects easier. That's an example of conserving energy. And the input force is lower using an inclined plane, but the object travels a greater distance. The work required is always the same. Oh, my artwork. A wedge. A wedge is a device that tapers into a thin edge, usually made of metal or wood. It is used for splitting, lifting, and cutting, and is a type of inclined plane. A pair of inclined planes that move, which is also a wedge. It applies an output force greater than your input force, but you apply your input force over a greater distance. That is the mechanical advantage. And a longer and thinner wedges create a greater mechanical advantage. A screw. A screw is an inclined plane that is wrapped in a spiral around a cylinder. When the screw is turned, a small force is applied over a long distance, used mostly as fasteners. The longer the inclined plane is compared with its height, the greater the mechanical advantage. An example of something that has a large mechanical advantage is a jar lid. Levers. Levers have a bar that pivots at a fixed point called a fulcrum. Levers are used to apply force to a load. Class 1 levers. The fulcrum is in between the input force and the load. It can be used to increase force or to increase distance, whichever one. Class 2 levers. The load is between the fulcrum and the input force. Class 3 levers. The input force is between the fulcrum and the load. A pulley. A pulley has a grooved wheel that holds a rope or a cable. A load is attached to one end of the rope and an input force is applied to the other end. On the first one, which is a fixed pulley, the input force is you're pulling down on it, and the output force is the load moving up. An example of that is an elevator. It has a mechanical advantage of 1. The next one, which is a movable pulley, you're both pulling up on it, which is the input force, and you get the output force, or the distance of the load is moving up. It has a mechanical advantage of 2. And the next one, a block and tackle, it has 4 separate rope segments and you have to pull the rope 4M just to lift the load 1M. The MA depends on the number of rope segments. And when you're pulling down on it with your input force, the output force is moving upwards. A wheel and axle. 2 circular objects that of different sizes. The wheel is larger of the 2. So the wheel is the big one on top, and you use the input force to turn it, and then the axle goes down and turns the output force, which unscrews the whatever substance, or like unlocking a door. And it's used to open stuff like doors and things. The mechanical advantage equals the radius of the wheel divided by the radius of the axle. Compound machines. They're machines that are made of 2 or more simple machines. An example of that is the block and tackle earlier in the pulley section. The 2 little ones are wedges. I drew those. And they are used to cut paper. Oh, this is our compound machine. It's scissors. And in the middle, the wheel and axle is used to move it back and forth. And the 2 levers on the side make it easier for you to push down the load to cut the paper. Conservation of energy. Yeah. It's good for lazy people. And it also states that energy cannot be created or destroyed, although it can be changed from one form or to another. So that's like if you have a hammer, which is the lever by the way, and you're pounding on a nail, your force that you apply to it is going down and into the wood that you're pounding the nail into. And conservation of energy applies to all of the simple machines that we talked about. You conserve energy by pushing the incline plane up this thing by just turning the wheel and axle instead of unhooking the water and stuff if you're doing a faucet. Pulley instead of lifting it up like on a big crane, you can just use the strings and so on. And like wedge, cutting a melon, instead of breaking open the melon with your hands, you can just cut it with a knife. The end. Yay! Thank you. And there are examples more to come if we can get our movie maker working. Thank you and goodbye. Leather, that's wrong way. My knife! Stab, stab, stab! Holy. And you messed up my drapes. Wheel and axle. Oh. Okay, so there is a screw. Sniff it, George. My Dorothy door stopper or my binder can be an inclined plane. Ready? Stop it. Breaking news just in. We have news of a screw around town. Let's bring it over there. Follow me. Just like come on, cameraman. Okay. Now, who are y'all exactly? I'm Tina. Tina from Idaho. And this right here, my friend Star Fox. Star Fox, look up, honey. That is Star Fox. Star Fox, look at me. I need your beautiful makeup. Feel good about yourself, honey. Okay, well, you see this screw right here? That's a screw. Ow. So, yeah, this isn't working. Hello, and I'm Tiffany Hillside, and today we are reporting from a Ringgold Playground trying to find us some simple machines. I think I found some now. Hey there! Who are you? Hi. I'm Tina from Idaho. Who are you? Wait, tell me again.
Star Fox.
His name is Star Fox. How about that? Okay. Love you. she precious? What do we have here? It is the wheel and axle. Spinning round and round. Yeah. Aren't they precious? Hello, my name is... Okay, will you just... George, stop barking, you idiot. Try to film.